Hi class, today we're looking at Chapter 8, Lesson 2, Reflections and Symmetry. Reflections appear everywhere in the world around us. You can see reflections in a mirror, or in a pool of water, or in shapes in art and nature. A reflection is a transformation that flips a figure over a line. Let's write that down. So reflection is a transformation that flips a figure over a line. The line is the line of reflection. So the line of reflection is the line a figure is flipped over. So let's check out this diagram. So C is just this right here, so the black one, C, and then it just has a little apostrophe above it, are the same distance from the line of reflection. So right, this is the line of reflection, and they're both the same distance. This one is 1, 2, 3 places that way. This one's 1, 2, 3 places that way. This segment connecting C and C apostrophe is perpendicular to the line of reflection, right? So perpendicular means that it forms a 90-degree angle. That's perpendicular to the line of reflection. So the line of reflection here is the y-axis. So if we were to look at this chart, A has the points 3, 2, right? Goes over 3 places, up 2. Then graph its image over the reflected, or after it is reflected, over the x-axis. So it wants us to use the x-axis as the line of symmetry. The line of reflection. So we can see that this is 1, 2 places from the x-axis. So this one's going to be 2 places. Okay, so the coordinates of A apostrophe are 3, -2. So let's look at this. After we've covered those, try this one on your own. Come back to me when you're done. Start out by graphing the points for D, -2, 1. Then graph its image after it's reflected over the y-axis, and then name the coordinates. Press pause. Come back to me when you're done. Okay, so you should have first graphed this point and then graphed this point, which is at 2, 1. The x is 2, we went over 2 places, up 1. So graphing reflections of shapes. Graph BCD and its image after it's reflected over the line through 3, I think I might have forgot a letter, a number there. I did. This should be 1, 3 and 1, 0. Name the coordinates. So that means we've been previously using the x and the y axis as the line of reflection. Now it's saying that it wants us to use it as over 1, up 3, and over 1, 0. This is our new line of reflection. So we ignore the y and we're counting from here. So this one is 1, 2 places from the line of reflection. So this one's going to be 2 places. Let's do that a different color. This one is 1, 2, 3, 4, 5. So we're going to do 1, 2, 3, 4, 5. This one's 1, 2, 3, 1, 2, 3. Okay, so now it says name the coordinates. So this first coordinate, and I'm sorry, this one previously was named C, B, D. So this is going to be still D, C, and then B flips to this other side. So now it wants us to identify these points. So now the important thing is we can, don't look at the line of reflection. We've got to go back to looking at here's our Y, here's our X. Okay, so let's identify B first. So that's going to be 1, 2, 3, 4, 5, 6. And then up 1, 2, 3, 4. That's B. C. It's going to be over 1. Oops, I tried to do it again. 1, 2, 3. X is 3. Up 1, 2, 3, 4, 5. And D. 1, 2, 3, 4. Up 1. So these are the coordinates. Okay, here is one for you to try. So first you're going to have to graph it, and then it's reflected over the x-axis, right? So this is the x-axis. So then after that, it wants you to name the coordinates of the reflection. Press pause, try to figure this out on your own. Come back to me when you're done. Okay, so you should have a figure that looks similar to this. And when you found the points, you should have found them to equal these. Notice, ooh, I forgot right here. You've got to put that apostrophe so that we can identify that they are reflections. Okay? So if a figure can be reflected over a line so that the reflected image matches the original figure, then the figure has reflectional symmetry. The line that divides the figure into mirror images is called the line of symmetry. Let's write that down. Okay, so the reflectional symmetry is if a figure is reflected over a line and matches the original figure. And the line of symmetry is the line that divides the figure. Let's look at an example. So draw the lines of symmetry for the snowflake below. So there are 6 ways to fold the figure so both halves match. That's the important thing, they have to match. The figure has 6 lines of symmetry. So we have one line here. If we put those together, they would match exactly. 2, 3, 4, 5. And, ooh, I missed that one. 6. 6 lines of symmetry. So looking at this flag, copy the flag at the right. Draw the lines of symmetry. Remember, it has to match exactly, so keep that in mind. See what you come up with. Come back to me when you're done. Okay, so really the only line of symmetry is right down the middle. That way green matches up with green, red with red, black with black. If we were to cut it this way, then the green would touch the black and they wouldn't be exactly the same, right? If you looked at it, it would not be exactly the same. So the only line of symmetry is straight down the middle. Okay, so let's look here. So use the graph at the right and match each point with its image after a reflection over the given axis. So here is A, and it says over the y-axis. So it is 1, 2, 3, 4 places from the y-axis. So we're going to go 4 this direction, 1, 2, 3, 4. So that means that it is matched up with D. H, right? Oh, I guess I should have gone to B. B and the x-axis. So here's B, and it's 1 spot away from the x-axis. So therefore G is its reflection. H and the y-axis, so here is H and the y, so it's 1, 2, 3, 4, 1, 2, 3, 4. E is matched up with H. And now looking at E and the x-axis, it is, here's the x-axis, so it's 1, 2 spots from the x-axis, so we're going to go up 2 spots, and D is its reflection. And then let's look at F and the y-axis. Here's F, y is going to go back 1, 2, crosses the y-axis, 1, 2, G. And last but not least is C, and it says the x-axis. So down 1, so cross the x, down 1 more, therefore F. So your homework for tonight is page 261, number 9 through 19 odd. Happy homeworking!